In this section, we will learn about instrumental analysis. Many industries nowadays need rapid and accurate methods for analyzing their products, and they need to check if there are emissions produced during manufacturing process. So they will use modern instrumental analysis such as flame emission spectroscopy and chromatography. Instrumental techniques are also important in the work of environmental agencies fighting pollution. Using sensitive instruments is now also common in healthcare. For example, healthcare agencies will check if titanium alloy hip replacement joints are still in good condition. To do so, they will check the blood of patients that have received the new hip joints, and they will test for any traces of metal ions originating from the metal alloy. What are the advantages of the modern instrumental methods compared with the traditional methods? First of all, they are highly accurate and sensitive. They are much quicker, and they enable very small samples to be analyzed. So the modern instrumental methods are highly accurate and they are sensitive. They will save time because they are really quick, and they enable very small samples to be analyzed. However, there are some disadvantages for using these instrumental methods, which are that the equipment is usually very expensive, so the prices of the machines are really high. In addition to that, it takes a special training to use, so not anyone can use these machines. People using these machines should be well trained before. And the results produced can often be interpreted only by comparison with data from known substances. Let's describe now flame emission spectroscopy, which is a common instrumental method. Chemists will use flame emission spectroscopy to analyze samples for metal ions. First of all, the sample will be heated in a flame. The flame will provide energy, and this energy will excite electrons in the metal ions, making them jump into higher energy levels or energy shells. And then, when the electrons fall back to the lower energy levels, the energy will be released as light. So, the sample will be heated in a flame. When heated, the electrons will be excited and they will move to a higher energy level. And then, of course, they will lose this energy and they will return to lower energy levels. While returning to the lower energy levels, the energy will be released as light energy. In the spectrometer, the wavelengths of the light produced can be analyzed by passing it through a spectroscope. Actually, each type of metal ion absorbs and gives out its own characteristic pattern of radiation, and this is called the line spectrum. So over here we have the line spectrum of common metals. The line spectrum can be used to identify the metal ions by comparing it with a database held on a computer. Not only we can identify the identity of the metal, but also the concentration of the metal ions present, so we can determine the concentration of the metal ion present in the sample by measuring the intensity or the absorbance of light with a specific wavelength known to be characteristic of a particular metal ion. The flame emission spectrometer can be calibrated using solutions of metal ion of known concentrations. So first of all, you have to use samples containing a known metal ion, and you know the concentration of each sample. And then you will plot an absorbance graph. Then you will place your sample which has an unknown concentration, and by comparing the value of absorbance measured, you can find the concentration. Flame emission spectroscopy provides an accurate ways to monitor water for metal ions. So, for example, we know that the heavy metal mercury is a dangerous toxin which can build up in our body. Flame emission spectroscopy can help us detect any mercury present in water. Also, other pollutants such as zinc and lead can be detected as well. Flame emission spectrometers are also used in the steel industry. So steel is a mixture of elements with iron. The steel makers need to control carefully the amounts of trace metals present, as the quality of steel depends on this. So they will measure the amounts of trace metals present to make sure that the quality of the steel they are producing is good enough.